Alrighty, this is going on page 88 when we are done. And we have put the angles on the unit circle in degrees and in radians, found our ordered pairs, which give us our sine and cosine values, and then we're going to look at what we can do for any angle and not just our special angles, trying to apply some triangles back to this unit circle. So this says, in the previous lesson you found trigonometric functions for positive acute angles. We will now find trigonometric functions for any angle. So in order to do this, we have to know our trig, know our SOHCAHTOA. Remember, that is a review from geometry. So this SOHCAHTOA is going to be important to us. Remember, this means sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Okay. So it says here, let theta be an angle in standard position, in standard form, and P, point P being at XY, be a point on the terminal side of theta. So here's my theta angle, right? Here's the point, which is at XY. It says the distance from point P to the origin is R. That's our radius, because if this point rotates around, we're going to make a circle, so this is our radius. So then the distance from P to the origin, R, the radius, can be found using this formula blank, which is the Pythagorean Theorem. All right, so here's what we know, is that this ordered pair right here, and how we figured it out from our unit circle, is this is my X value, right? This is my Y value, and then the hypotenuse is the radius. So the Pythagorean Theorem is a squared plus b squared equals c squared, or using these variables here, we're going to get x squared plus y squared equals r squared. So, knowing our trig for SOHCAHTOA, knowing what this is x and y here, and we have this little right triangle, we're going to be able to use this here as our reference angle. We're going to be able to find sine, cosine, tangent, and cosecant. Right? So sine is opposite over hypotenuse, so the opposite is y. Hypotenuse is r, so this is y over r. Cosine is adjacent over hypotenuse, so that's x over r. Tangent is sine over cosine, or opposite over adjacent, so that's going to be y over x. These next three are just the reciprocals. So cosecant is the reciprocal of sine. It's r over y. Secant is the reciprocal of cosine, which is going to be r over x. And cotangent is the reciprocal of tangent, which is just x over y. So in geometry, we talk about sine, cosine, and tangent. Once you have these three down, you got the next three because they're just the reciprocals. So tangent and cotangent are the only two where the reciprocals have the same name, like tangent and cotangent. So sine and cosine are not reciprocals of each other. Sine is the reciprocal of cosecant, and cosine is the reciprocal of secant. So there's only one co in each pair, think of it that way, and none of the pairs of reciprocals start with the same letter. So what I mean by that is you're not going to put cosine with cosecant. That doesn't make any sense. It's cosine with secant, sine with cosecant, and then tangent's the reciprocal of cotangent. Okay? And this whole x, y, r thing, you can always relate it back to a right triangle with your SOHCAHTOA to keep all of that straight. Okay? So, number one says, point P, which is at 9, negative 12, is a point on the terminal side of theta in standard form. Find the exact values of the trigonometric functions of theta. All right, so we need to draw a little picture here. So I'm going to draw my little x and y axis. This point here, that is 9, negative 12, is going to be in the fourth quadrant because I have a positive 9 and a negative 12. So 9, negative 12 would be somewhere kind of like that. And so here would be the radius part of that. Right? There's my little triangle. So I make this with the x-axis. The triangle is always made with the x-axis, never with the y-axis, because remember our reference angles are always the shortest way back to the x-axis. So here's my little right triangle. This is where my theta is. I don't have a lot of room, so I'll just mark it instead of writing a theta in there. So what I know here then is that my x value is 9, so this is 9. My y value, this is a negative 12. And then this is r. Okay? So if I want to find these trig functions, there's some that I can already come up with just fine because I have the opposite and adjacent, right? So if this is my angle, opposite and adjacent, or my x and my y, I can put y over x, or opposite over adjacent, and that gives me tangent. Tangent's opposite over adjacent, so I have negative 12 over 9. I can reduce those both by 3, and so this gives me negative 4/3. That's the tangent of theta. I don't know what theta is. We're not finding that yet. That's just the tangent ratio. Okay? Since I know the tangent, I can come up with the cotangent because it's just the reciprocal. So this would be negative 3/4. So I've got those two answers down. But in order for me to find these, sine is opposite over hypotenuse. Well, the hypotenuse is the radius and I have an r. I need to actually find the value of that instead of just using the r. So I can do that using my Pythagorean theorem, right? So from Pythagorean theorem, I know that 9 squared plus negative 12 squared is equal to r squared. So this is going to give me 81 plus 144, and it's positive because it got squared, equals r squared. So r squared equals 225. R technically equals plus or minus 15, but since this is a length, it's positive. This length is technically a positive 12 because it's a distance. The y value is just negative 12. That's why I put that. But the length here of the hypotenuse always going to be positive, so r is just equal to 15. Okay. So what I got from all of that then is that, again, I know my x value is 9. That's coming from the ordered pair. My y value is a negative 12. And then my r value is 15. Okay? So now I can find the rest of these because sine is opposite over hypotenuse, or y over r. So my y is a negative 12 over r, which is 15. Can divide those both by 3. So that's going to give me negative 4/5. Then once I find that, the reciprocal of sine is cosecant, so I get negative 5/4. Cosine is adjacent over hypotenuse, or x over r. X value is 9 over the radius, which is 15. I can reduce those both by 3, so that gives me 3/5. The reciprocal of cosine is secant, so this is 5/3. So that's how easy that is to come up with it. You have to draw your little picture so you can get in the right quadrant, so you have your signs correct, your SIGNs, the positive and negatives, and so you know which quadrant you're in, and you get all the plus and minus signs correctly, and then have to do a little Pythagorean theorem there. Okay, so let's do one more of these. Let's do number 2. So we have this point, and I'm going to draw my little x and y axis here, and then negative 6, negative 2 is going to be in the third quadrant here. Okay. My right angle, this is my theta over here. So this is negative 6, this is negative 2, and this is r. All right, so then I need to do my Pythagorean theorem so I can come up with all of that. I can already do, a couple of these, but we'll just wait and do them all. So I have to do negative 2 squared plus negative 6 squared equals r squared. So this is going to give me 4 plus 36 equals r squared. So r squared equals 40. So r is going to give me the square root of 40. but I have to simplify that square root. Okay, so 40 is 4 times 10. I can take the square root of 4. The 10 just gives me 2 and 5, so it's going to stay underneath. So I get that r is equal to 2 square root of 10. Got to be able to simplify your square roots quickly and accurately. So here's my r. So what I have then is that x is equal to negative 6, got that from my ordered pair. Y is equal to negative 2 from my ordered pair. R is equal to 2 square root of 10 from my Pythagorean theorem. Okay, so now I have to set up these and correctly be able to reduce them. Sine is y over r, so your y is negative 2, and your r is 2 square root of 10. So what happens here then is that the 2's are going to cancel out, right? The 2's cancel out. That leaves you with 1 over the square root of 10, and it's negative, but you can't leave a square root in the denominator. You have to rationalize, which means we would multiply this by the square root of 10 over the square root of 10, so that we end up with negative 2 square root of 10 over 10. Right? Oh, it's not negative 2 because that 2 canceled out. What the heck? I'm making stuff up. So it's not negative 2. I'm sorry. That 2 canceled out, so it's just 1. So it's just the square root of 10 over 10. Let me undo that here. But let's say that this was it, which it's not. But if it was, then I could reduce the 2 and the 10 there. But that's how I caught myself. I knew I wasn't supposed to do that. All right, so sorry, the 2's canceled out. That's why I marked it out. I still tried to use it. So this is just a negative 1 times the square root of 10. So I get square root of 10. And then the 10 times the square root of 10 times the square root of 10 is just 10. And then overall, this was negative. That's my answer, the correct answer. All right, so then the cosecant is the reciprocal of sine. So I got a couple options here. If I take the reciprocal of this as it is, I'm going to get a square root in the denominator again and have to rationalize again, which is fine. It's really not that big of a deal. However, if I back up to this step here that I didn't really write very cleanly because I didn't need to here, this is negative 1 over the square root of 10. If I take the reciprocal in that form, that's just going to give me the square root of 10 over negative 1, which is negative square root of 10. All right, so then cosine of theta. We've got cosine, which is x over r. And so that x is going to be negative 6 over 2 square root of 10. All right, so I can reduce this, the 2 and the 6. So the 2 goes into 2 once, goes into 6 3 times. And then I have a square root in the denominator again, so I have to rationalize. I'm going to multiply that by the square root of 10 over the square root of 10. And I'm not going to write that out every time, and you don't have to write that every time. I just want to make sure that you understand what we're doing rationalizing-wise. From now forward, when I rationalize, I'm going to say that's what we're doing, but I'm probably not going to write this fraction because it's just not necessarily to write it every time. You get negative 3 square root of 10 over 10. So now I need the secant, which is the reciprocal. So again, I could use this one, and I would have a square root in the denominator, then I'd have to rationalize. But here, where I couldn't leave it, because it's illegal to have the square root in the denominator, if I take the reciprocal of that one, it's just going to give me the square root of 10 over 3, and I don't have it in the denominator any longer, and it was negative. So you got to watch the signs there too. Okay, so then the tangent of theta. Tangent is opposite over adjacent, or sine over cosine, or y over x. So this is going to give me negative 2 over negative 6, which is a positive 1/3. Cotangent is the reciprocal of that, or it is x over y. And so the reciprocal of 1/3 is just 3. It is positive. All right. So now let's look at the signs, the SIGNs, not the SINEs. Signs of the trig function. This is very important as we're going to start putting all these pieces together. When we look at these angles and know what quadrant they land in, we have to know what the sign is of the value, meaning that it's either positive or negative. And so when we put our little ordered pairs around the unit circle, depending on which quadrant we're in, the x and the y change from positive to negative or whatever. And that's going to help us figure out what's going on in each one of these quadrants. So this says, depending on the location of the terminal side of an angle, trigonometric functions can be positive or negative. Using your knowledge of the trigonometric function values, identify the functions that are positive in each quadrant. Okay, so here's how this all works very nicely together. So we know a couple of things that we got to make sure we can write down correctly. First of all, is that our quadrants are 1, 2, 3, and 4. And you cannot afford to get that wrong ever again in your entire life. They are written as Roman numerals, and it's in that order, 1, 2, 3, 4. So something that you know that you've known forever since you started doing any kind of graphing is what's happening with your x and y values in each quadrant. So in quadrant 1, it's always a positive x and a positive y. In quadrant 2, it's always a negative x. Why am I doing that? Sorry. It's always a negative x and a positive y. Quadrant 3, x and y are both negative. Quadrant 4, x is positive, y is negative. So it looks like that. Okay? So here's what we can figure out from this. What we know is we know that our ordered pairs are cosine theta, sine theta. Remember when we figured all that out from the unit circle originally, your x values represent the cosine of theta, your y values represent the sine of theta. So, and then when you go and figure out tangent of theta is sine theta over cosine theta. So these are important for us to figure out if things are positive or negative. Okay? And here's how that works. In quadrant 1, okay, my ordered pair is positive, positive. That means cosine is positive and sine is positive, right? Then when I go to find tangent, since tangent is sine over cosine, that's positive over positive, so everything is positive. So all of the trig functions are positive in quadrant 1. In quadrant 2, since your x value is negative and your y value is positive, that means cosine is negative and sine is positive, all right? And then since it works that way, when you go to find tangent, you'd have positive over negative, which would make tangent negative. So since you have x value is negative and y over x is tangent, that's positive over negative, that means cosine and tangent are both negative. Your y value is sine, so the sine values and the reciprocal of sine, which is cosecant, those are positive in quadrant 2. In quadrant 3, sine and cosine are both negative, right? So both of these are negative, but then when you go to find tangent and you put y over x, negative over negative is positive, which means in quadrant 3, your tangent is positive, and so is its reciprocal, which is cotangent. In quadrant 4, x is positive, y is negative. So cosine is positive, sine is negative. So cosine's positive. When I do tangent, sine over cosine, that's going to give me negative over positive, which makes the tangent negative. So in quadrant 4, the only thing that's positive is cosine and its reciprocal, which is secant. Okay? So there's a little mnemonic that's going to help you remember this. So if you look at the first letter of all of these, right? So all of them are positive here. And if we just think about sine, tangent, and cosine, then the reciprocals just kind of go along with it. So you have this S, T, and C. So the little mnemonic is all students take calculus. And so there's your all students take calculus. All students take calculus. So you can get those letters in the right quadrants so you know what's positive and what's negative. So what we get from this, then, is that in quadrant 1, all of the functions are positive. In quadrant 2, it's sine, because sine is the y value, and your y values are what are positive here. So it's sine and the reciprocal, which is cosecant. In quadrant 3, sine and cosine are both negative, which means that when you combine them then to get tangent, you get that tangent is positive, and its reciprocal, which is cotangent. Quadrant 4, x is positive, so that means your cosine values are positive, and the reciprocal, which is secant. So again, here is your all students take calculus. So let's think about that idea and answer some of these questions. It says, remember the phrase, all students take calculus. There you go. So if cosine of theta is greater than 0, so if cosine is positive is what it's telling me, so I'm looking for cosine of theta being positive, which quadrant or quadrants would the terminal side of theta lie in? All right, so cosine of theta is positive in quadrant 1, because everything's positive in quadrant 1, and then it's also positive in the 4th quadrant here. Then it says if tangent of theta is less than 0, that means if it's negative, which quadrant or quadrants could the terminal side of theta lie in? Well, it's not quadrant 1, because everything's positive in quadrant 1. In quadrant 2, it's only sine that's positive, so tangent would be negative in quadrant 2. In quadrant 3, tangent's positive. In quadrant 4, it's cosine, which would mean tangent would be negative in quadrant 4 as well. Okay. So then it says if secant theta is less than 0, that means we want it to be negative, and secant is the reciprocal of cosine, so we're really talking about cosine. So if it's less than 0, it's negative. So in the first quadrant, everything's positive, so it's not that. Quadrant 2, sine is positive, which means cosine is negative. And then quadrant 3, tangent's positive, which means cosine's negative. And then in quadrant 4, cosine's positive. So those are the two. So then it says, if sine of theta is less than 0, so it's negative, and cotangent of theta is greater than 0 or positive, which quadrant or quadrants could the terminal side of theta lie in? And this and here is very important. And sine, we got that. Cotangent, we know, is just 1 over tangent theta. All right, so sine of theta being negative or less than 0. Sine is positive, positive, so it's these two quadrants here where your sine is negative. And so it would be quadrants 3 and 4. But then we have this and thing going on. And cotangent or tangent has to be positive. Well, tangent is positive in 1 and 3. So if I need sine to be negative, which is these two, and cotangent to be positive, and tangent is only positive in 1 and 3, 4 doesn't work. And this is my only answer for this one. Okay. All right. So now we are going to use the information that we have, our knowledge of what's going on in the quadrants. Okay, this might look like a lot, but it's really not that big of a deal for us to remember, so that we can figure out these exact values. So we're going to jump down to number 8. Okay. If what you have is not written in terms of sine and cosine, you want to rewrite it in terms of sine and cosine to be able to help you make more sense of it. So, and what we need for us to help us remember things here is this: all students take calculus. So remember, this is telling us if our sine and cosine values and our tangent values are positive or negative in each of these given quadrants. Okay, so what I know from this then is in quadrant 2, sine is positive, so cosine and tangent are both negative. Okay, and those all coming from the ordered pairs that you have on your unit circle. But the numbers we're getting aren't necessarily coming off the unit circle, because this is for any circle, not just the unit one. But we want to tie it to this idea. So again, we're going to rewrite things in terms of sine, cosine, and tangent if they're not in terms of that, so that it makes more sense to us. So we have cotangent of theta is negative 4. So tangent of theta is the reciprocal of that? Well, the reciprocal of 4 is 1/4, and it's still negative, so it's negative 1/4, right? And then secant of theta is greater than 0, so that means that we want 1 over the cosine of theta to be greater than 0. And the fact that it's the reciprocal doesn't really affect the sign, the SIGN. So secant and 1 over cosine, although the value would be different, whether it's positive or negative will remain the same, but this is what fits in our little thing over here. So when we have this, this is what we know. Tangent's negative. Well, tangent is positive here and positive here. So tangent's negative in this quadrant and this quadrant. And then we want cosine to be positive. Well, of these two quadrants, the only one where cosine is positive is this one. So it's quadrant 4 that we're using for number 8. That's important for us to get our picture drawn correctly so we get all the information on there correctly. So here's my little X and Y axis. I know that I'm in quadrant 4. So I'm going to have a little triangle in quadrant 4 here. Here's my angle. And what I have to be able to put on my triangle at this point is this 1 over 4, which is tangent of theta. Now let's say that I still had a whole number. If you have a whole number, you just put it over 1 so you get a fraction. So we know that tangent is opposite over adjacent. We also know that it's could be considered sine over cosine. And also we have that it's y over x. All three of those things basically mean the same thing. So opposite over adjacent, well, this is the y and this is the x, and that's what this is here. So the opposite is going to be 1, the adjacent is 4, or the y over the x. But one of them is negative. Not both of them, but because of this, one of them is negative. Since I'm in quadrant 4, the x value is positive, the y value is negative. That's why it's important to get it drawn in the correct quadrant, so you get the sign attached to the correct number. And then this is my radius. So I'm going to have to go and find what the length of the radius is, right? So I do Pythagorean Theorem again, like I did on the front. The difference between this and what we did on the front is on the front, we basically started with this. But on here, we have to decide which quadrant we're in to get the things positioned correctly. So now I do Pythagorean Theorem. Negative 1 squared plus 4 squared equals r squared. So this is going to give me 1 plus 16 equals r squared. So r squared equals 17, and r is just the square root of 17. That's a prime number, and it doesn't reduce. Okay? So what I have from here then is that my x value is a positive 4, my y value is a negative 1, and my radius is the square root of 17. So now that I have this, I can go and fill in all of my information over here. Sine, which is y over r, is going to be negative 1 over the square root of 17. Can't leave it like that, so I have to rationalize. And that's going to give me this negative square root of 17 over 17. Cosine of theta is adjacent over hypotenuse, or x over r. So this is going to give me 4 over the square root of 17. Again, I have to rationalize, so that'll give me 4 square root of 17 over 17. Tangent is opposite over adjacent, or y over x. So that's going to give me negative 1 over 4. And I'm done. I actually already had that because of what they gave me to start with. Cosecant is the reciprocal of sine. So again here, if I take the reciprocal of this in this situation, then I'm going to get the square root in the denominator. These two things have the same value. This is just written in the correct form. So if I take the reciprocal here, I won't have to worry about rationalizing. That'll just give me the square root of 17 over negative 1, or negative square root of 17. Secant is the reciprocal of cosine, so again, I'll use this one to take the reciprocal of, so it gives me the square root of 17 over 4, and it's positive. So make sure that you got the positive and negative things down correctly. You cannot just forget to write a sign. Like that makes it wrong, because if it's supposed to be positive and you have it negative or vice versa, it's not just an oops, I forgot to do that. It's a, oh, you wrote the wrong number, because it's giving you a completely different thing. Okay? All right, so let's do number 9. On number 9, it says we have the cosecant of theta is negative square root of 5 over 2. And so I'm going to rewrite that in terms of sine or cosine or tangent so that I can make some better sense of this. Cosecant is the reciprocal of sine. So the sine of theta is negative, and I'm just going to write this as 2 over the square root of 5. Now, although it's illegal to leave it like that as a final answer, I'm not going to rationalize here because I don't need to. I'm just getting it that way so I can get it drawn on my triangle. And then cosine of theta is cosine, so I'm good there. So I got to figure out which quadrant I'm in. So here again, I have my all students take calculus. And if sine is negative, right? So sine is positive here and here. Sine is negative here and here. But I want sine to be negative, and I also need cosine of theta to be less than 0, so I need it to be negative. So cosine is positive here, it's negative here. I'm in quadrant 3. So then I need to draw my little picture. And in quadrant 3, my triangle would be like this. And sine is opposite over hypotenuse, or y over r. So this is 2 in the square root of 5. Your hypotenuse is always positive. It's the y value that's negative in quadrant 3. And then your x value is also negative. I'll just label that as x because I'm going to have to go and find that. So now I will do my Pythagorean theorem. I get negative 2 squared plus x squared equals the square root of 5 squared. So negative 2 squared is 4 plus x squared. Square root of 5 squared is 5. So x squared equals 1. I take the square root of that, and remember, the square root is plus or minus 1. And in this case, your x value is negative, so x equals a negative 1. That's your x value there. So x is negative 1, y is negative 2, and your r is the square root of 5. And then once you have that, we can fill in all the rest of these by finding our ratios. So the sine of theta is y over r, or opposite over hypotenuse. So y over r is going to give me negative 2 over the square root of 5. Not legal, so I have to rationalize. Multiply by the square root of 5 over the square root of 5. So that gives me negative 2 square root of 5 over 5. Cosine is x over r, or adjacent over hypotenuse. So that's negative 1 over the square root of 5. And then I rationalize, so I get negative square root of 5 over 5. Tangent of theta, opposite over adjacent, or y over x, or sine over cosine. So it's going to give me a negative 2 over a negative 1, and then that reduces out just to give me a positive 2. Secant is the reciprocal of cosine. So I want to take the reciprocal when the square root's in the denominator, so this will just give me a negative square root of 5. Cotangent is the reciprocal of tangent, so I'll take the reciprocal here because the reciprocal of positive 2 is a positive 1/2. Okay. So this is the first half of the notes. Go back over it, make sure that you understand where all the pieces come from. If there's anything you have a question about, then we'll start tomorrow with me answering some questions, but you gotta ask me questions before I push forward on more of this to finish up tomorrow, okay? Because we're gonna put all this together so we can go and calculate some things. So I'm not giving you an assignment that goes with this today. You won't get it until tomorrow. So now if you haven't finished those mazes, go and finish them. And remember, I know it says show all of your work. You don't have to show the work on the ones that you should know from the unit circle. I want you to try and think about those without just straight up converting. But some of them that aren't the special angles, you are going to have to convert. Okay?